Welcome back, everybody. Alright, we're going to continue our discussion on special segments that you can form in triangles, and we're going to move that discussion to where we're talking about now medians and altitudes. In this video particularly, we're going to focus on medians, and you will solve problems using properties of medians of triangles. Alright, so what is a median and what kind of properties go along with a median? That's what we need to explore right now, so let's do that. And I'm going to talk about the concurrency of the medians of triangles in particular. Now, we do need to know what a median is before we can really say much about the concurrency. A median of a triangle is simply a segment that connects a vertex of a triangle to the midpoint of its opposite side. Now, I'm going to draw all three of them, so I'm going to make all three midpoints right now. And then here is an example of a median. I'm going to connect A to the midpoint of segment BC. There you go, segment from a vertex to the midpoint of the opposite side. And let me mark some indications that that is actually a midpoint right there. Alright, and then the other two medians then would go from B to the midpoint of segment AC and from point C to the midpoint of segment AB. And you can see they intersect right there. And I'll tell you what that point here is called in just a moment. I want to give some names to these midpoints. So let's just say we've got point D, E, and F. Those are all midpoints of their respective sides. And let's call the point of concurrency there, let's name it point P. So we can see that the medians are concurrent, and the point of concurrency of medians turns out to be called a centroid. Now that's the third type of triangle center that you've learned about, in addition to the circumcenter and incenter with perpendicular bisectors and angled bisectors respectively. Now, unlike those other types of centers, the centroid isn't equidistant from anything in particular, at least not in most circumstances. Under special circumstances it is. It has a whole nother type of property which is pretty cool, and I'm going to show that to you right now. Let's say we just pick one of these medians and we focus just on that. I'll highlight one of them, that median segment BE. Here's the thing that's true about the centroid. It turns out that if you're traveling along the median from the vertex end of it to the midpoint of the opposite side, that the centroid is always located 2/3 of the way along that segment. It's 2/3 of the way from the vertex to the midpoint of the opposite side. Now, another way of saying that is that the distance from the centroid to a vertex of the triangle is twice the length of the distance from the centroid to the midpoint that is the median connects to that other vertex. Let me write this in equation form. I'll write a few different equations just to describe all the relationships that you see. The distance from B to P is 2/3 of the distance from B to E. Alright? Or I can say that the distance from B to P is equal to twice the distance from E to P. Alright, centroid is located 2/3 of the way from a vertex to the midpoint of the opposite side along a median. Excellent. So we're going to put that property to work in a couple of problems now. In this picture, it tells you that P is the centroid of triangle XYZ, and it also tells you some distances that would have been tough to mark on the diagram, so they're just written out in the directions. The distance from P to Z is 21. Now I guess that's easily enough labeled. Let me do that. Then the distance from P to M is 5. Distance from Y to N is 18. Now that would be tougher to mark because, well, there are two segments that kind of make up that segment YN, so I'm going to leave that off the drawing. But what we're going to do is we're going to find three other distances using that information. The distance from L to P, Y to P, and P to X. And we're using the fact that the centroid is located 2/3 along the way from the vertex of a triangle to the midpoint of the opposite side. Alright, let's look at segment, or the distance from L to P. And I want you to find out which median that distance is a part of. And it turns out that that distance is a part of the distance from Z to L. Alright, now PL happens to be the shorter part of that median, right? And I have essentially told you that the longer part of a median is twice the length of the shorter part of a median whenever the centroid is drawn there. And so we can say what's half of 21? 10.5. That's going to be the distance from L to P. Okay, then the distance from Y to P, you can see that that is right here. And that happens to be the longer part of median YN. Well, what do we know about this median YN? We know the entire distance from Y to N is 18. And I've told you that the longer part of a median is 2/3 of the entire thing. So 2/3 of 18 is what we're going to use to find this. I'm going to write this out in words first, sort of. And then I'll substitute the numbers. YP has to be 2/3 of YN, and 2/3 of 18 is going to give you 12. All right, and then finally the distance from P to X, which is again the longer part of a median, the median XM. And what we're going to use for that is the fact that it's twice as long as the shorter part, and we know the length of the shorter part. PX has to be twice the length of PM, so it's 2 times 5 or 10. Very simple. All right, one more question to do in this video. We're going to look at a triangle that's graphed on a coordinate plane, and what I'm going to want us to do is to find the coordinates of the centroid of that triangle. Now there's a couple different strategies that we can use to make this happen. I'll show you the one that makes the most sense by definition of a centroid, and then I'll show you the one that actually kind of works out to be the easiest. By definition, the centroid is located wherever the medians of a triangle intersect one another, and so if I go ahead and find out where those medians intersect by finding the midpoints of the sides, then I can go ahead and find out where the centroid is. So I'm going to draw the midpoints here, but I'll also remind you of how you find the coordinates of the midpoints. That would be a midpoint of AC, this would be the midpoint of AB, and this would be the midpoint of BC. And remember, you can use a midpoint formula to find the coordinates of those points. So, like for instance, for AC, I would average its x coordinates together. -6 plus -9 is -15. -15 divided by 2 is -3, it's -7.5. And then average the y coordinates as well. 6 plus -2 is 4. 4 divided by 2 is 2. So -7.5, 2. If you didn't know where the midpoint is, that's how you would have found out the locations of these midpoints. But I've got the midpoints there. Now let's go ahead and draw the medians, and let's see where they intersect one another. So here's the median from A to segment BC. The median from B to segment AC. And then the median from C to segment AB. And the point where they intersect is the centroid, and you can see that, and the coordinates of that point in this case happen to be what? Let's see, -1, 2, 3, 4, 5, 6, 0. Alright, there you go. So easy enough to draw the three medians and see where they intersect. Truly, you could have just drawn two of them because they're all three going to intersect in the same place, so wherever two of them intersect is where all three would intersect. Alright, now the other thing that you could have done is looked for a median that was either a vertical or horizontal line, and it's nice whenever this works out this way. We did have one. This median from A to the midpoint of segment BC was a vertical line, and then you can use the fact that the centroid is 2/3 of the way along that segment from the vertex. Since it's vertical, you could easily count that this distance is 9 units long, and so you would have to have gone 6 units, which is 2/3 of 9, towards a midpoint in order to find out where the centroid is. That would have gotten you to -6, 0 as well. That's all you need to know about medians. Thanks for watching, guys. See you next time.